For what types of advanced manufacturing jobs are you seeing the most hiring?
I'm sorry.
Go ahead.
I would say mill lathes. These are CNC tooling machines. I don't see a lot in engineering. I see mostly in quality control and women running machines, the CNC machines, the high-level 5-axis, and these are giant computers. Places are clean, places are air-conditioned, temperature-controlled. I mean, it's amazing. And they're right. They're all spread out. Like I said, we deal with about 80 different clients right now where we move and migrate machinists. And the biggest ones are lathe operators, mill operators, people who can set up and do basic programming on the CNC machines.
I think that's a good point right there. The last statement there was that we're not looking for somebody to come in and have a senior operator or a senior setup person set up a piece of equipment and have somebody come in and stand in front of it and put parts in it. Basically, our technicians are going to come in and they are going to do their own setup. They're going to make their own adjustments. I was having lunch with my uncle last weekend, and he started a machine shop in Rochester a long time ago, and he was talking about how that is going now. He's retired from it, but he stays and keeps his fingers in it, and he was talking about the people that they're looking to hire and how those roles have changed from when he was there, where you would have a lathe that was set up and somebody would come in and operate it all day long and make pretty much the same parts. Now we need to make 2 or 3 of these, and then we're going to change over to something else and make 5 of those. And so it's those mixed skills, I think, are the things that we look for. And as far as types of jobs, I think, from what I hear from being around guys like this, we're all looking for people. So
I'll bring a slightly different perspective, not being a manufacturer myself. With our technology program, we have a dozen full-time students. We started just last fall. We require co-op experience for the students. One of the students started working full-time at Optimax even before the classes started for the program. So he worked the 3rd shift and came to class at 8 o'clock. Another student got a co-op opportunity to work at GW Lisk just a week and a half ago to work with another engineer to use LabVIEW software and other hardware for designing test system for aerospace, solenoid, and other components. So these components need to be certified and tested for every piece which is being shipped out. You're not just doing sample testing. And so this student, he just finished 1st year of courses, is doing co-op there. We have a student who is going for interview this Thursday, well, that'll be tomorrow, from in a company in Victor, which is construction robotics, and they needed someone to help integrate robots in creating machines for laying bricks and other construction jobs. So just looking at the 3 or 4 students who have just finished their 1st year and starting co-op, and they have this opportunity, and some of these students have gotten multiple offers after they had already accepted a co-op. It leads me to believe that these are the type of jobs which are available because, one, that just aren't people who are trained to do this kind of things. One could take an engineer and send them away for training of this type. They can come back and do the job. But I don't believe that there is an efficient use of engineering resources at a company.
I would just add that, because I get called all the time by companies. My phone probably get at least 3 calls a week, companies trying to hire our students. So I ask what jobs and what things are you looking for currently, because they know coming out these aren't experienced machinists. These are folks who either change jobs or they're brand new students. And as I said, at CNC, they're looking for programmers. They're looking for people to set up. Quality is really driving the boat a lot right now, because in order for you to do aerospace, medical, you have to have quality certifications. So you need people that can do the quality tests, and oftentimes that takes the same kind of skills that a machinist. You have to know how to set it up, how to hold it, how to run the CNC coordinate measurement machine. So we're seeing a lot of push for quality folks. I did a job fair a couple of weeks ago. We had 30 companies there. We had 4 or 5 mold making companies. They're looking at bringing mold makers on. Mold makers, machinist, high levels machinists. So they're looking for people with some CAD, a little bit of CAD, computer aided design. They can look at that. Computer aided manufacturing, how to pull that together. So it's a broad base of skills, but a lot of it really falls back into a lot of machine trades. But I will say also that I know we're talking about machining today, but electronics is driving a lot of the boat right now also. We're getting places like RF Harris that are getting some excellent contracts. I don't know if you ever look at the Rochester Business Journal. They've been bringing in amazing amounts of contracts in the electronics field right now also, which is in a very highly sophisticated field that you would need some training in. So these are some of the jobs that I think are really driving the boat out there right now. So.
Great. The next question is, how well do these jobs pay, and how long does it take to see your salary increase?
I have some information on that from the Dayton article that I had here, and their survey found that entry-level positions paid between $20,000 and $30,000 a year, and skilled positions pay $40,000 to $80,000 a year, and I think that that's pretty close in line with what we would be paying at Optimax. An entry-level position at that level might be somebody straight out of high school with that had been in a career and technical education program at BOCES and had learned machining and things like that. Somebody at a more skilled position might be someone that's coming in with a bachelor's degree in mechanical engineering or something like that. So it's a pretty broad range. As far as how quickly things advance, that really depends on performance, basically.
Our positions that I really spoke to as far as pay goes, I looked at our numbers, and really they're about the same. Most of our positions in the machining and out on the floor, technicians that we're looking for are hourly positions. But the starting pay is anywhere from $12 to $14 an hour. And a machinist, for instance, can earn as much as $25 an hour, in some cases more. And since most of these positions are hourly, there's oftentimes shift incentives and overtime opportunities that can push you up into some pretty good annual salary. As Todd was mentioning, the people, the mill and lathe people that he's talking about, the advanced people, they make some very good pay. And they're so sought after that they can pretty much name what they want and where they're going to work their hours. Now the other thing is that most of the machinist and manufacturing positions, these technician positions that we're talking about, with the degrees that Sam and Bob are talking about, really you can look at as a pathway as well. Most of these things can act as a pathway into engineering and so on, which the pay salary just continues to climb from the numbers we're looking at. As far as how long does it take salary to increase, I talked about starting wages. We talked about things in the numbers in the 20,000 range or so on. Because the skill set is so advanced and involved, most companies realize that when somebody comes in with brand new training that has never done this before, they understand their skill set is going to develop and hopefully at a very rapid pace. Typically, they'll be reviewed with increases in mind at least once every year, and many times every 6 months, where they're reviewed. If they're doing well, if their skills are advancing, we want them to go up through. We want to keep them engaged. You're developing new skills. You're getting more efficient at what you're doing. That $25 an hour you can steadily work towards as you're working. So it's a pretty quick pace to get from that starting salary up into the much higher ranges.
Yeah, and Dave, let me help on that. You can increase your pay not only by your skill set, but your attitude with working within a shop. For every one of these guys has made mention to, I need you to do multi-different jobs. If you come in and you're a CNC mill guy and the mill's not running that day, sweep the floor. Ask someone else if they can help. Show up every single day. Be open and honest. One benefit of having a whole bunch of small shops is they're run by families. And these shops turn into families, and they care about you. And if you're working hard and you're that person who's helping out and not going to the water cooler and talking about everybody, you're going to advance your pay. That's 100% up to you and how you're supporting your company. If you're the people that sit around the water cooler and criticize and condemn and are looking for another job, well, then I'm going to come in and we're going to talk a little bit. And then you know what? These guys will probably be happy to have you leave because you're only a Sora. But I've seen more people get increased by their attitude. Maybe your skill set's not as good as Jim's. Maybe he's just phenomenal at it, but maybe Jim's not have the right attitude. And I've seen people who have the right attitude advance a lot farther in a company than people who don't have that. So I would say with the smaller shops, it's not a big, huge company like Kodak where everyone's scaled, everyone every year gets it. These are families. These guys know that if they have someone who has that, they're going to make sure they hold on to that person tight and they're going to treat them well.
We did a survey within last year because we have worked with the advanced manufacturer right from the get-go. We needed their help to design our curriculum. Their survey indicated that the starting pay for graduates of a 2-year degree program would be from mid-30s to mid-45s. In a way, that was a little bit surprising for me because the instructors who started our college full-time, for which we require a minimum master's degree, we barely pay them starting salary of $40,000. So here's a 2-year degree with the right set of skills and experience and, of course, attitude and other soft skills as well. One could do a lot better from the get-go.
Thank you. Next question. Are you seeing any trends in skills that applicants for those jobs may be lacking?
I think some of the things that Todd mentioned, it's surprising when you find people who don't understand that you expect them to come to work every day. I don't get it. Another thing is that I know a lot from talking with some of the people at MCC. Math skills are generally an issue. It's a common problem, and you get people to say, "Well, I don't really like math." Well, it's like you can like it or not like it, but you're going to get a lot farther if you like it than not, or if you, whether you like it or not, if you can use it, it's going to help you move forward. And so that's one thing that I encourage people to do is brush up on their math skills. I was fortunately one of those people who liked it, and it's a weird thing, I don't know, so math, I think, and some of the soft skills, showing up for work, things like that, those are things that are, I think out of some of the people that we've hired this year, those more of the soft skills of being at work every day were things that cost these people their jobs after a short period of time.
I think in general, soft skills, communication. I mean, that for more and more companies. I was just in South Carolina for a conference last week, and they took us to a company, an advanced manufacturing company, and they showed on one of their computers every night that the people that run the machines, the operators, could log on, and if they had a problem, say what the problem was, so the folks on the next shift could see what was going on, and it went up to engineering staff, And, I'm reading some of this thing, it's broke down, it was very vague. So I asked them, what is the communication skills? And they said, well, we actually do have to train these folks to speak the right language. What's broke? Why is it broke? Because that stuff now can be tracked back. Literally, emails can be used in a court of law, where if you sent out a communications and it was misinterpreted, it can come back. So communication skills, I'm hearing from more and more companies, are becoming critical because people are, at all levels, are talking closer. I went to one of the mold shops I visited and I asked him, who is your highest paid guy here and why? And he said, the highest paid guy here is not the most technically savvy, he is our best communicator. It's the person who can talk to our customers, our staff, relate to the folks that are running the machines. That's a critical skill. So that's important. You've got to be able to express your thoughts and communicate properly.
And another thing that I would say, as far as trends in skills that applicants may be lacking, computer literacy is critical. Everything we do, our shop is completely littered with computers, and everything we do is attached to a computer. I don't see this as that much of most people are pretty computer literate, and we can teach them the stuff they need to know to work in our shop. But if you're not computer literate, that's a substantial problem that you need to fix. Because I think that's probably true in all of our cases.
I think the soft skills are in general, you've mentioned a lot of things that were mentioned around our place. And broad-based, that really is, in manufacturing in general. One of the other things we get into is the specific skill set. And things like being able to read and understand engineering drawings. As we said, manufacturing's advanced. Now you have to understand statistical process control, geometric dimensioning and tolerancing. You need to be able to use a myriad of high-tech precision measuring machines to measure these parts. Operators are going to use computerized measuring machines. All these different things, all these precision gauges, that goes along with all these soft skills they speak of. So we have this soft skill, but we also get into the technical skill stuff, and that even applies into people that are coming from transfer that used to run machinery but didn't move along with the computerized stuff. This is the skill set that we need to address for our needs.
One of the things we heard from the business leaders is that it's not just enough for a person to have appropriate technical skills, but be able to understand and communicate business case for technology. No matter how good your technical solution is, but if it does not make a business sense, then stop, do something different, ask for help.
All right. There's a three-part question here that I think a lot of people, possibly in the audience, are wondering. First, how can I train for a job in advanced manufacturing? And how important is it to have a college degree? And on top of that, what type of degree would be best? Anybody want to challenge?
I'll take a whack at that. As far as training for a job in advanced manufacturing, like I said earlier, because our companies are so diverse, the best thing to do would be to look at the skill sets that are required by all the companies: metrology, measurement, quality systems. If you're getting into CNC machining or things like that, Cartesian awareness of the X, Y, and Z axis, the multi-axis machining. But and the other things beyond that, the math skills, brush up on math, computer literacy, make yourself aware of those things. And if you do that, that's a foundational thing that's going to translate regardless of what industry you end up moving toward. As far as an Optimax college degree, sorry guys, but it's not huge for us. We hire as many kids that are right out of high school as we do bachelor's degrees and higher. I mean, we have everything from GEDs to PhDs at Optimax. So it's so if your degree is in the right discipline, well, that's got value. But if it doesn't, If it's not, it really doesn't. It's not a huge factor in our decision. More interesting for us is your willingness to learn new things and continue your education. We pay 100% tuition reimbursement. Actually, it's not even tuition reimbursement, it's tuition assistance. So we pay for you to go to school if you're going into some of the classes that Bob or Sam are offering. In fact, I take a class every semester, so it's, and you just have to, those are the things that I would say. So as far as what type of degree would be best, it's hard to say. Working toward an engineering degree helps you learn a lot of good stuff, but whether it's a critical thing, we don't hire a lot of engineers per se. We're really much more heavy in technicians than engineering group. But we do have engineers, so that's my 2 cents.
What I would say, coming from obviously a training background, is Jim was saying, we're not seeing a huge push for degrees. They want skills. Okay. How can we get a lot of folks, obviously I'm not talking to a high school audience here. So we've got some folks here that have been out in the field doing some different stuff for a while. So it's what can I do to get my foot in the door to get a job? And it's the skills training. At MCC, we have a certificate. It can be done in 1 year. It's going to give you the solid skills in CNC, being able to read prints, the applied mathematics, that's going to have places like Optimax give you a second look, or GW List give you a second look. It's going to give the skills that you really need to get started. The problem out there right now is we're talking small companies, lean. They've got just enough people to get the job done. They do not have staff to train new people. So if you're not coming in with some skills to start with, where they have to literally babysit you, it's going to be a problem. So these are the skills that we're hearing from the manufacturers that they want. They want them to be able to know how to get onto a control panel on a CNC machine and know their way around on it. Know how to do tool offsets. What tools would you use in a program? How do you read a print properly? And then the basic math that goes along with it. We have an associate's degree. I really encourage our younger students coming out of high school to go that way, because we said that's going to help you climb the ladder. All right, it's going to make you a well-rounded person. One of the things that I thought was real interesting is just what Jim was saying. I get a chance to visit a lot of companies, and coming out of GM, to be an engineer at GM, you had to have a minimum of a bachelor's degree. All right, so when I started visiting these companies, I just asked what kind of degrees, and I found about 70% of the engineers in the local manufacturing industry have no degrees. And I visited one of our aerospace companies, very high-tech. These guys are doing jet engine parts. So I ran that statistic by him. I said, being aerospace, very sophisticated, are most of your folks with bachelor's degrees in engineering? He said, no, same exact thing. About 70% are folks that started on the floor and worked their way up to that position, because the experience is critical. So these are the things that I think they're really looking for, is the desire to learn, get the basic understanding of machining principles. And a lot of folks are coming in here in this group, I'm sure today, with an additional background. And I have seen folks come through our program that have come in with some background that have moved very rapidly up in companies by taking a program like ours or Sam's, getting their foot in the door, and then utilizing their past experience to propel them to different areas in the plant, especially quality. We've seen a few folks move rapidly into quality off of the machining floor because of past experience. So that's, from our perspective, that's some of the things we're seeing. I know LISC has a great program out there. It's not credited, but it's giving the solid skills that's going to be manufacturing based that anybody's going to want to hire somebody that's going through their training program. So there is a lot of good stuff going on out there to get the basic skills to get you your foot in the door.
Last fall, I took dozen plus students out for visits to the high-tech companies, and one of them was Optimax. One of the young fellow who showed us did a demo on some precision optics manufacturing equipment. It turned out that this person was actually a gas station attendant, had no college experience, but because of their person's ingenuity and ability to learn quickly, was able to learn a great deal and perform at much higher level. So in a way, as an educator, it is inspiring for me to see how small, medium-sized companies are able to take human capital and motivation and help them learn skills and perform at a much higher level that often the education system has very low expectation for education system things. Unless you go through all this training, you cannot do anything, or very few people are able to perform certain type of complex task. So yes, the degree is helpful, especially if a degree involves training which makes you quote unquote liberal arts for technology type of person who is able to handle multiple different technologies as well as teamwork and other use the soft skills. What most people probably do not realize that currently with the engineering pipeline, I probably mentioned earlier, only about 20% of people actually graduate after 6 years of college education, not 4 years. 4-year graduation data is even lower. So what is happening to the rest of these people? Are they just switching major, going into business or doing something else? Perhaps so, but that is a big loss for the country. What we have done with our educational program is to simplify approach to mathematical skills. Basically provide apps and tools to visualize mathematics. By doing that, we can help people learn algebra, pre-calculus, along with skills like computation using Excel, LabVIEW software, and other software, which eventually makes a person a lot more capable than a traditional engineer who may have had half a dozen calculus courses. So when you hear from some of the people here who say that often the engineering work is done by people without the engineering degree, that is very much true. And part of that is availability of other tools that people can use, and of course, individuals' ability to learn, assimilate, and integrate the experiences.
And just to elaborate on that, as Sam mentioned, one of our guys that was formerly a gas station attendant. When we get a new piece of technology in, this person immerses themselves in the manual, and within a very short period of time, they understand the equipment better than anybody. He understands the equipment better than anybody in the shop, and turns out he's the go-to person if you have a question about some part of that technology. So that is it's just an illustration of that thirst for learning, that appetite for learning, and that's a perfect example.